Alright, hi Nixon. Doing the cumulative review. So question 1, determine the x-intercepts, y-intercepts, the end behavior, the domain, and the range for each function shown. Okay, x-intercepts is where it crosses through this line. So we've got our first one is -3, then -2, then 2. Our y-intercept is where it crosses through this line, and that is at -12. Our end behavior is the quadrants that it goes through. So this is first, second, third, fourth, and it's going from the third one up to the first one. Q3. And the domain is how far sideways it goes. And for a cubic, it's always going to go all the way that way and all the way that way. So it's just x is all real numbers. X is an element of real numbers. And the range obviously goes up the whole way and down the whole way. So the range is the same. Y is an element of all real numbers. Okay, and then for this one, let's just copy across this. Okay, for the other side, intercepts at -3, 1, and 3. Our y-intercept is at here, -9. The answer for that is wrong. The answer says that it intercepts at 9. They missed the negative sign. End behavior starts off at quadrant 2 and then goes down to quadrant 4. So Q2 to Q4. The domain again goes all the way that way and all the way that way. X is an element of all real, and range it goes up the whole way and down the whole way. So range is y is an element of all real. Sweet. That's question 1 done. Next one, we've got determine the degree, the sign of the leading coefficient, and the constant term of the equation of each polynomial function shown in question 1. Okay, so let's go back up. The degree, the sign, and the constant. Okay, so constant term, we already know, is always just going to be the same as the y-intercept. And we've gone over that before. It's because when you make x 0, which is along this line, the only term that's not affected is going to be the y-intercept, which is the constant term. Because it doesn't have x attached to it, right? It'll be like y equals ax cubed plus bx d. And this d is the only one that doesn't have x. So when you 0x, all these get zeroed as well, and you're just left with d. But we've already been over that before, so I won't go too in-depth into it. But because of that, we can just go immediately and put -12 here, come over here, and put, what's the, degree, sign, and constant, and put -9 here as well. Just fill those in quickly. It's pretty much a useless question to have. Okay, degree. Both of these are cubic functions because they have 2 turning points is one way of deciding it. Also just the shape, right? If it goes like that or that, it's going to be cubic. In this case, it makes it really obvious that it's cubic. If it's an inflection like that, it makes it harder because it's based on how sharp the inflection is. But for this, 2 turning points, it must be cubic, because the amount of turning points will be the degree minus 1, so degree is 3. The sign, it's an odd degree, right? And it starts from the bottom left and goes to the top right. So it's a positive sign, so plus. For this one, we've got the same shape, so the degree is also going to be 3, 2 turning points again. But the sign, it starts from the top left and finishes in bottom right as an odd function, which means it is going to be a negative sign. Okay, 3, determine the possible number of x-intercepts, the y-intercept, the end behavior, the possible number of turning points, the domain, and the range of each function. Okay, there's not really space down here, so I'm just going to erase these top answers to make room, and just work up here instead. Sweet. So 3a. Okay, number of x-intercepts. The shape of the line, it's going to be a straight line like that. So at most, it's going to have 1 x-intercept. So 1. It's not saying what the x-intercept is. It's saying possible number of. Then it's saying what is the y-intercept. So let x equal 0. And the y-intercept is going to be negative 2. So take that and write that down. The end behavior. Oh, actually, I'll make this an equal sign. The end behavior is you've got a positive linear function. So it's going to look like that. Doesn't matter about this intercepting because it's talking about end behaviors. You've got 1, 2, 3, 4. And it's going from 3 up to 1. So Q3 to Q1 is going to be our end behavior. And then also I'm looking at the answers here. They actually put what the x-intercept is instead of saying the possible number of x-intercepts. So they've answered the question wrong. So don't mind that. And if you want to find the x-intercept, you just let y equals 0 and rearrange. So I think you do know how to do that. If you don't, just send me a message and I'll do a video on that as well. And then the possible number of turning points is always going to be degree minus 1. So our degree is 1, right? Because there's like an imaginary 1 on that x there. And so degree minus 1 is 0. So turning, none. And then the domain and range, again, it's a positive linear function like this. It goes all the way up and down, and it goes all the way side to side. So the domain and range are both just going to be all real numbers. So domain x is an element of all real, and range y is an element of all real. So easy. Alright, that's the first one done. I'm just going to erase and work in the same space. And you can always go back and rewatch if you want to get the answers for that specific question. B of x. So this is a parabola because it has a degree of 2. And it's got a negative sign in the front. And so that's pretty much all the key information. Now we're going to go a little bit faster on this. So max number of x-intercepts is 2 because the degree is 2. Our y-intercept is the term that doesn't have x attached to it, so negative 8. Our end behavior, we have a parabola that's negative, so it looks like that, and so it's going to go from 3 to 4. So Q3 to Q4. our number of turning points is the degree minus 1, so our degree is 2. So degree minus 1 is going to be 1. Our domain is from, goes the whole way sideways like that. So x is an element of all real. Our range, as you can see, it's an upside down parabola, which means this is going to be our max point, right? So we need to find this turning point there. So we do that by either going halfway between the x-intercepts, or we figure out the turning point using negative b over 2a. So I think halfway between the x-intercepts is the easier way of teaching it. So if we have negative x squared plus 4x minus 8, you can go 8 and 4. You can just use the quadratic formula. Oh, actually, okay, there's going to be no x-intercepts because that turns negative. So then you do just have to do this. So negative b on 2a is going to be the midpoint, with b being this number, so same as the quadratic formula, and a being this number. So negative 4 on 2 times negative 1 equals 2, because negative 4 and negative 2. So at x equals 2, our y is going to be at the turning point, and that's going to be our maximum value of y. So the x equals negative x squared plus 4x minus 8. Well, the sub in that value just found 2, negative 4, because 2 squared is 4, plus 8 minus 8. Those two cancel each other, so it's negative 4 is going to be the y value at the turning point. And remember, because of our shape, that's going to be our maximum y value, right? Because the turning point is the maximum within negative parabola. So it means that y is going to be less than or equal to negative 4 as our yeah, wait, what? The answer says less than or equals to negative 6. That is not correct. I'll even double check though on Desmos for you, just to make sure. I've already put all our tables in, that's why all those numbers there. But let's chuck it in. Y equals negative x squared plus 4x minus 8. Is that the question? Yep. And what? Oh, there we go. What's our maximum? Yeah. So at a turning point, our maximum is going to be negative 4. So the answer got that wrong. What's the wrong thing? The actual answer is actually y is less than equals to negative 4. And that actually proves my point on Desmos. It's kind of useful. See, it's an upside down parabola, so that turning point is going to be the maximum value. I'll just make a new expression book. Okay, sweet. Okay, and then that's it for B. Now on to C. Actually, I can keep that. Erase that. Sweet. For C, our degree is 3, so our maximum number of x-intercepts is going to be 3. That's just always the case. It's not saying that you will have 3, it's saying that's going to be your max amount. Like for this one, for example, we didn't have any x-intercepts, but our maximum amount was 2. Okay, so that's 3. What is our y-intercept? That's always going to be the constant term, so negative 2. End behavior it is a positive cubic, so it actually looks something like this. So it goes from 3 up to 1, so Q3 to Q1, and then turning points, possible number of turning points is degree minus 1, 3 minus 1 is 2, and domain, same as this one, it's the same shape. It's going to go all the way sideways, and range, it's going to go all the way up and down. So domain and range are both going to be all real. That one was a little bit quicker, especially because we didn't have to dispute the wrong answer. Yeah, there we go. Okay, last one is also cubic. Maximum degree, not maximum degree, the degree is 3, so maximum number of x-intercepts is going to be 3. Y-intercept, there is no constant term, so treat it as plus 0, so it's 0. And then end behavior is the same as this one, because it's a negative cubic function. So it's going to go from 2 to 4. The amount of turning points is the degree, or the number of x-intercepts, minus 1. So 2. Our domain is, again, same as this one. So all real, and y is all real for the range. So yeah, you can go through it pretty quickly as soon as you understand the steps for each characteristic. Okay, so that is all done. Now, on to the next is to do with this table. Saying the amount of energy consumed to heat a building on the first day each month over 15 months is shown in the table. Create a scatter plot and determine the equation of the cubic regression function. So it does specify, before I go into a cubic regression function, we already know that. We've got our scatter plot here. I've put it in to save time. And cubic regression function y1 tilde ax1 cubed plus bx1 squared plus, this would be so much faster on my laptop. Oh, why is that button not working? There we go. Cx1 plus d. Oh, I missed a plus sign. I was going to say that shape looks very wrong. There we go. Okay, that suits it pretty closely. And all of our letters here, we just sub in. So, A equals 4.80872. B equals, you know how to fill that in now, so I'll just, so you put in what A equals, B equals, C equals, and D equals, and then you just write y1 ax1 cubed plus bx1 squared plus cx1 plus d, and then that's your answer. Sweet. And actually this might even be an equals, and then you don't need these ones down here because it's asking for the actual equation of the cubic regression function. Okay, use your graph to estimate the time period when the energy consumed to heat the building is less than 150 degree days. Okay, so the amount of energy used is our y-axis, so we're going to add an expression and say y equals 150. And so when it's between those, it's between 0 and that intercept, 0 and 0.584. So 0, that 5 was weird, 584. over here it's less than it as well. So between 8.678 and 12.867. And then the actual question is asking for the time period. So I think this is meant to say in. Well, I think it's meant to say in days. So we want our total answer. So we add up this, so 0.584 plus, and the difference between these two numbers. So 12.867 minus 8.678 is 4.189. And so our total time period is going to be 4.773 days or months? Oh, months. Which means this is actually wrong, not in days, sorry. Okay, so that's done, and then we want C, use the key regression function to determine the degree days needed to heat the building on the day that corresponds to the end of the 7th month. So end of the 7th month is when the 8th month starts, right? So in here we go plus expression, zoom out, x equals 8. And that number there, 267.659, so 268 degrees. Assume end of 7th equals. Because it says state any assumptions you made. Okay, predict the characteristics of each exponential function. Record your predictions in a table like the one shown on the top of the next page. Verify your predictions using graphing technology. Okay, so we've got this table. I'm just going to write these so I can zoom in. A is 5 times 3 to the x, and B is y equals 30. So we've been over this in the chapter 7 assignment, I remember. In terms of like the shape of these graphs. So I'll just draw a quick sketch. We know that because 3 is bigger than 1, 3, as the power gets bigger, so as x gets bigger, is going to get bigger. And then this one, because 0.1 is less than 1, the more times it multiplies by itself, the smaller it gets. So it's going to get smaller. So that's the general shape. As you can see, it's never going to reach or get lower than 0. So we've got an asymptote there. And it only has one x-intercept on both of them, and that's going to be the same actually at, not x-intercept, one y-intercept, and it's going to be the same at x equals 1. So we can chuck that in right now. At y equals 1, at x equals 0. Because if you let x equal 0, that is completely wrong. If you let x equal 0 here, this turns to 1, and then it's 5 times 1. So that's 5. So for A, it'll be 5, and for B, it'll be 30. My apologies. Okay, number of x-intercepts will be 0 for both of them. And then end behavior, this one's going from 1 to 2. This one's also going from 1 to 2. No, wait, it's the other way around. I need to slow down a little bit. It goes anti-clockwise, I just remembered. So it's 2 to 1 rather. So 2, 1, 2, 1. The domain is going to be all real, right? Because it goes all the way that way and all the way that way. And that's the same for both of them. And the range will also be the same for both of them. They're never on or below that line. So it just has to be greater than 0. increasing or decreasing. A we can see is increasing, and B we can see is decreasing. So if you aren't sure about how I figured out the increasing and decreasing part, just go watch the assignment 7. It's in the table, it's the last 2 graphs. They basically look exactly like this, just with slightly different numbers. Population, so that would be assignment 7 part 1, by the way. The population of the regional municipality of Wood Buffalo, Alberta has grown rapidly since the discovery of one of the world's largest oil deposits. Its population in 1996 was 35,000 and has grown since at an annual rate of 8%. Create a table of values that shows the population of Wood Buffalo from 1996 to 2006. Okay, so we start off here. Have our table. '96, 7, 1998, 99, 2000, 2001, 2002. Six. And then do that. So I know it's not the neatest table in the world. It doesn't really have to be. Okay, so at 1996, it's 35,000. Now it says it increases at an annual rate of 8%. So to make this table, you take the number that's in here and you multiply it by 1.08. That's an increase of 8%. And then, so that, let me grab my calculator, 35,000 times 1.08, 37,800. And then now you take this number and multiply it by 1.08. So 40,824. 1999. 44,089.92. 47. Oh. And I'm sure you can fill in the rest of the values yourself. So just keep multiplying by 1.08 basically. How do you know that an exponential function can be used to model this context? That's the best way I would summarize it. I don't know exactly what the answer says. Actually, at a constant rate. So basically all I'm saying is if you draw it, the gradient's always getting steeper, right? Which is only going to happen with an exponential graph. Because if you have a parabola, for example, it's not always increasing. Like here, the gradient, well, it's increasing, but it's going down, the actual function. So maybe instead of gradient, I should say function. Growth. I think this doesn't even, it's not, they're not going to be nitpicky considering half their answers on this are wrong in the first place, but this should be a fine definition. The exponential function that models population of growth is that, so it's basically what we were doing, right? where x represents time in years and y represents blah blah blah. Determine the y-intercept of this function. What does it represent in this context? So y-intercept, we let x equal 0. Y is going to be 35,000 because it's 35,000 times 1.0850 is 35,000 times 1 is 35,000. So then what does it represent? Well, when x is 0, which is the time, it's the original population. Which we know is 1996. Graph the function. Use the graph to estimate the population in 2011. Okay, so y equals 35,000 times 1.08 to the power of x. I can get rid of all of these three. Expression. Y equals 35,000 times 1.08 to the power of x. Whoa. The power of x, rather. Sweet. We're going to have to zoom out real far to see the y-intercept. Oh wait. Oh, here's 30. I was at 300. Okay. 3, 4, 5. And as you can see, it's at that point, 0, 35,000. That's where it starts. And we want to go expression. In 2011, we're not going to chuck in x equals 2011 because it starts at 1996. Like that, right? So to get to 2011 minus 1996 is going to be 4 years, so 15 years. So we're actually putting in x equals 15. So with that, x equals 15. Oh my word. Should click on the green one. Actually, why am I doing this? Just sub it in. So 35,000 times 1.08 to the power of 15. Is 111,000. So 111 is down here. If we zoom in, keep going. The intercept's somewhere along here. I'm just wasting time doing this. But and 25. 25.9 is B. Oh my word, I'm at 110,000. Sorry, you can skip ahead. I just want to prove that this method works. If you just plug it into your calculator. 125.9. What? How am I back down at this? $111,000. Jeez. As you can see, when you're working with big numbers on Desmos, it gets really weird. But the lines have basically merged here. 98. That's down here. All of this just to show you that plugging into the calculator works. 919. And it's not even letting me zoom in any further. So, oh, there we go. Oh my word. Okay, and then that's the intercepting point, which is the exact thing the calculator gives. So, jeez. Okay, there we go. When the population exceeded 100,000. So then just change this function to say y equals 100,000. Zoom out, tons. And then find that point. No. There we go, 13.641. So 13.641 years after, so it'll be 2009.641, so mid-2009. Okay, 200 gram sample of radioactive polonium 210 has a half-life of 138 days. The mass of polonium in grams that remains after T days can be modeled by the exponential function. Create a graph of the function. 200, 1 over 2, x over 138. One, two, x 138. Sweet. Determine the mass that remains after 5 years. So it's T days, right? So after 5 years, it's 5 times 365, which isn't technically true because you have leap years and stuff every 4 years, but 1825, I'm assuming they did not account for leap years. Wait. They just got this completely wrong. They said after 5 years, and this says after T days, and then they just subbed in 5. I'm so terribly sorry, Nixon. You guys keep giving you the completely wrong answers. Do you get what I'm saying here? Like, they define T as the amount of days. So, you know, T in 5 years would be 5 times 365, which is 1825 days. So T equals 1825, not T equals 5. That's just basic maths. But whatever. So their answer, they just go T equals 5. So we'll do that, even though it's wrong. So x equals 5. Here I was saying they probably won't account for leap years. They literally didn't even account for their own questions, like correct answer. They intercept somewhere here. If I make them different colors, that would probably help. But whatever. Basically, I'm just checking when x equals 5 becomes the function on the left. Which is there. So just follow it along. And they should intercept. Oh my goodness, okay, I'm just going to make this a different color. Which I don't know how to do. Okay, again, just sub it into your calculator. I don't know why I keep using Desmos. They keep saying to, but like, 200 times 1 over 2 5 on 135 is 195. If you want the actual correct answer, you'd sub in that, so 200 times 1 over 2 to the power of 1825 on 138. So the actual answer was 0.0209 grams, but their completely wrong answer, which is the one they're looking for apparently, is this one. Determine the length of time needed for the sample to decay to 50 grams. So you just say 50 equals 200. Now you can do this using algebra, but like, oh, actually, 1 on 4 equals, and 1 on 2 squared equals, so 2 equals x 38, x equals 138 times 2, which is 276. Or you can come to this and put in y equals 50. Zoom out and find that, and that's 276. So either way you get the answer of 276. I'd use Desmos if you don't know how to do what I just did, if you're not following along there. Because it's just the easier method. Okay, so that's done. I'm getting increasingly frustrated because they keep having wrong answers, but it's fine. I wonder who writes up the answers for this. Okay. Biologist checks. Oh, wait. T, not X. It's up there. So, days. Which, yeah, they actually are so dense. If it takes 276 days, which is less than a year, to get to 50 grams, how is it supposed to be at 195 grams after 5 years? Like, the answers don't line up with their ones, because it's just wrong. But sorry, I'll stop ranting about that. So, biologist checks, C, create a scatter plot, which I already did earlier. So we have our scatter plot. Delete that. Turn on those dots now and press that. Sweet. Turn the equation of the exponential regression function. So exponential is a b to the power of x. So here, y1 tilde a b power of x1. Oh, sorry, it's 2, not 1. I was wondering why there was nothing popping up. Okay, there we go, sweet. And that fits it pretty nicely, so it's pretty obvious it's correct. Again, just take the values of a and b that they have for you over here for part 1. Part B, I mean. Part C, explain how the parameters in the equation are related to the context. Well, the parameters, you can say like the start. Obviously, if you take this whole equation, you can go into like negative over here. But in our context, our start is actually at this point where y equals 0, that's the starting population. Yeah, so that's all there really is. So I'll just say y-intercept is original population. And parameters is just talking about the domain and range. Determine when the population will exceed 1,000. Come over here. Plus expression y equals 1,000. And zoom out. Find that point, 8.335. And t is defined as years, so 8.335 years. Okay. Shown is the graph. How much longer do we have left? Okay, not long. Shown is the graph of y equals 25 log x. State the x-intercept, the domain. So the number of y-intercepts, the end behavior, the domain and range. Okay, so x-intercept is 1, because that's just the default x-intercept for a log graph. And we know that because y equals 25 log x, 0 equals 25 log x. Now we can just, this number in front doesn't matter, right? Because you divide both sides by 25. 0 equals log x. And then it's saying what? So 10 to the power of 0 equals x. Sorry, that's the rearrange. And then 1 equals x. But it doesn't matter what this number out in front is. When you do that step, it always gets cancelled because you just divide by that number. So it's always going to be 1 unless your numbers, like inside, changed. So it's like log x plus 1, then it changes it. So for this one, I'll just do it down here. 1 number of y-intercepts. We went over this in assignment 7. If it's logarithmic, it does not have any y-intercepts. The end behavior, it's going from 4 to 1. And the domain and range. Domain, it can't be 0 or negative. X is greater than 0. Range, it can be any number. Y is an element of all real. Sweet. So that's question 9 done. Predict the characteristics of each logarithmic function. What? X-intercept will probably be 1. None. 4 to 1. X is greater than 0. We're predicting it for these two, I guess. Okay, that makes way more sense. So for A, this will all be true. And for B, most of it will be true. Y is all real. For A, increase, and B, decrease. And that's just based on that sign at the front. This is a plus sign, and that's a minus sign. I'm not going to graph them because we're running out of time, but you can graph them if you want to see, and those answers will be correct. Oh, wait, shoot. This one, that's A, and then B will be from um 1 to 4. Is there anything else that changes? No, there's not. Okay. Martin is a fruit grower in the Okanagan Valley. He's planted and tracked the growth of a new variety of cherry tree. Create a scatter plot for the data, which I've already done. What? Oh, okay, there we go. So delete that. and delete that. Yeah, sweet. This is our data. Determine the equation of the logarithmic. I'll just go on it so you can see. Logarithmic regression function, which is going to be in the form a log x plus b. So y3 a log x plus x 3 plus b, and I need to show these points, zoom in, and that fits it quite nicely. Again, you copy your a and b across to get that first part for the equation of the logarithmic regression function. Determine the height of this tree when it's 15 years old. Come across, I'm not even going to bother typing it in. Oh. When it's 15, it's 22.777 feet. And the age of this tree when it's 12 feet tall, again, not going to bother typing it in. Just go 12 and go on it. Oh, it's not showing me. Okay, I actually do have to type it in. Y equals 12. 2.753 years old. Name the common characteristics of the graphs. Number of x inches. What? Infinite? Like, between what domain? If it's in general, it's just gonna be infinite. Okay, they also, again, have not answered the question. It says number of x-intercepts. They give you the actual x-intercepts. Okay, but if they want the actual x-intercepts, sine looks like this. And this point here is 180 degrees. So it starts at 0, which is an x-intercept, so 0. And it goes both ways. Plus minus 180 degrees times n, where n is an integer, so n is an element of z. And then cosine, literally don't need to redraw anything, it's just, well, okay, wait. There we go, shift this whole thing across, so it's like that. That's 90, and that's negative 90, that's 270. So it just shifts the whole thing across by 90. The y-intercept will be 0 for sine and 1. The domain will be all real for both. You can literally just graph these on Desmos and then pick out these features. The range will be from -1 to 1. The period is, if you go like, start here, how long does it take to go back to the same spot? Which is 360 degrees. And then amplitude is how far up it goes, which is 1, because if that's the 0 line, it goes up to 1 and down to -1. And the equation of the midline is y equals 0, because it runs along the x-axis, right? So this middle line is going to be at y equals 0. Sorry, my mom just sent me a message. Okay, sketch the graphs of both functions on the same axis. Okay, basically what I just did, but I'll redo it. So we'll go pink for sine. Oh, actually it needs to go 4 times. So that's 180. Oh wait, 360. Oh wait, no. 5. And then needs to keep going a little bit. Which is 2 pi. And then this is cosine, it starts here. It's just the whole thing shifted. Oh my word, I'm literally just gonna do this. Style. And then this would just keep going. Sweet. Okay, and then a group of students is tracking a friend, John. Describe this graph by determining its range. How much is left? Almost there. As he rides a Ferris wheel, created a graph that shows his height over the ground at various times on his ride. Describe this graph by determining its range, the equation of the midline. Okay, so it goes from 10 to 2. So that's the range. Equation of midline, halfway between 10 and 2. Just step like down and up. So 10 goes to 9, 2 goes to 3, 9 goes to 8, 3 goes to 4, 8 goes to 7, 4 goes to 5, and then 7 goes to 6, 5 goes to 6, 5 is in the middle. Or you could just like eyeball it and you can see pretty easily that it's in the middle. So y equals 6, it goes up by 4, so amplitude is 4, and the period, if you go from here back up to the same spot, it's at 10, and at 100, so period is 90 seconds, because the time is in seconds. Discuss how these characteristics of the graph are related to the Ferris wheel. Okay, so the height, just chuck that there. Wait, oh, sorry, it's 1, not 2. That's 1. And that's 11. My bad. The midline's still the same because we went down and up by 1. I just can't read apparently. Okay, so that means since it starts at 1, we can say diameter actually instead of height. Equals 10 because it goes from 1 to 11. Get on at 1 meter off ground because that's the minimum height. And that's all you really need to say, I think. For each of the following sinusoidal functions, state the amplitude, period, the equation of the midline, the domain, the range. Okay, I'll do this another time. I'm getting so tired of these questions and they're wrong answers. So sorry about that, but I'll help you if you really need help with these ones. Just let me know. Bye.